Hello, and welcome to another live session at the Reactor. This session is in collaboration with Learn Live. Before we begin, please take a moment to read our code of conduct. We are all here to learn, so please be respectful of other people's views and opinions. The chat will be open throughout, and we do encourage you all to participate. My name is Rav, and I am the program manager at Reactor London. As you all may know, that tomorrow is International Women's Day, and the team wanted to give a huge shout out to the amazing women in AI for helping us put together this series. Thank you, Amy Boyd, Victoria Holt, Carlota Castelluccio, Bethany Jepchumba, and Ruth Yakubu. This definitely wouldn't have been possible without your support. Today is the second episode of the three-part Azure AI Fundamentals series. In today's session, you will learn all about how to analyze images with computer vision service. This session will be led by Carlota Castelluccio, Cloud Advocate at Microsoft, and Bethany Jepchumba, Microsoft Learn Gold Student Ambassador. I also wanted to let you know that this series partners with the Microsoft Certified Azure AI Fundamentals certification. So if you follow this link on the screen, you can enter into our 30 days Learn It challenge, which we are hosting as a part of this series. By completing the challenge, you can be eligible for a 50% off the cost of a Microsoft certification exam. So follow the link, which I will be posting in the chat very soon. Carlota will be discussing this in more detail in her presentation. So now with that, I'm now going to hand over to our lovely speakers, Carlota and Bethany, who will lead the session. Hello.
Hello. Hi, Rav. Thanks for your introduction. So hello, everyone. Good morning, good evening, or good night, depending on wherever you are in the world. Thanks for joining us today for this Learn Live session about how to analyze images using Azure Computer Vision Service. I'm Carlotta Castelluccio, Cloud Advocate at Microsoft, focused on data science and data analytics. And today I'm here with Bethany, our Gold Microsoft Learn Student Ambassador. Hello, Bethany. How are you?
Hi, Carlota. I'm very fine. As Carlota mentioned, and also as Rav mentioned, I'm Bethany Jepchumba, and I'm a Gold Microsoft Learn Student Ambassador, and I'll be joining Carlota today for the session. So thank you all for joining in, and I hope we have a lot of fun together.
Thank you, Bethany. So, as you may know, this session is the second episode of an Azure AI series designed to help you get started on a Microsoft Azure AI learning journey. To give you an overview of what you can do using cognitive services in different technological areas. So in this series, we will cover 3 modules of the learning path designed for Azure AI Fundamentals certification. So if you attend the 3 episodes, you will be well on your way to get the certification. So if you missed the first episode, catch it up and make sure the next episode is already on your calendar. Bethany, did you get certified for Azure AI Fundamentals?
Yeah, I got my certification early last year, and the voucher was based on the Student Ambassador program. So if you want to participate, you can also join into the Student Ambassador program. And I already had some knowledge on Azure and AI, but I wanted to now solidify my knowledge and expand on now the different Azure AI capabilities. The certification was very in-depth. I got to learn a lot. It covered different techniques such as machine learning, natural language processing, conversational AI, and of course, what we're covering today, computer vision. Yeah.
Thanks for sharing your experience, Bethany. So I didn't get certified yet, but the exam is already on my schedule, so I'll take it very soon.
Yeah, before we get started, I'd like to introduce our moderator on the chat. He's Joshua Demenge, a cloud advocate on AI. Joshua, can you just say hi?
Hello. Hi, everyone. My name is Josh. I'm a cloud advocate on Microsoft, and I'm excited to be the moderator for today's session. So any questions you have, drop them on the chat, and I'll be glad to answer them. Thank you.
Thank you so much, Josh. And in case you have any question, be sure to drop them on the chat. He'll be ready to answer you.
Thanks, Josh. Thanks for your support today. So today we are going to talk about computer vision service and how to analyze images using this service. We will guide you through the Learn module at the link on the screen, hopefully giving you some good tips. You can also use the QR code below to navigate directly to the Learn module webpage. And after this session, we also encourage you to go back to the module, complete it at your own pace, watching videos, practicing with the exercises in a way that today you can focus on this presentation. Bethany, we have a few learning objectives on our agenda for today, right?
Yeah, today we are all about computer vision. So we'll be covering what exactly is computer vision, the theory behind it, and then find out what are the different tasks the computer vision cognitive service can be able to perform. Then we'll go into now exploring the resource on Azure by provisioning a computer vision resource, and finally do a demo on now having the computer vision resource we've provisioned in action. So you'll be able to see all through from what concepts are we learning, what exactly is it, why is it important, and finally a demo on it. Yeah, so let's first get started with what exactly is computer vision and the theory behind it. Computer vision is one of the core areas in artificial intelligence and focuses mainly on creating solutions that enable AI-enabled applications to basically see the world. From this, the computer vision are capable of now processing images either from a live camera feed or from digital photographs and videos. And this ability enables them to now get the key details and emulate the human vision. So they can actually be able to emulate how exactly you see the world and give us now the results and make sense of what exactly in the images and give us the different results. Computer vision is very applicable in our day-to-day lives and also in the industry. So, Carlota, can you tell us some of the capabilities of the computer vision service?
Yes, of course. So as you just said, Bethany, the computer vision cognitive service uses pre-trained models to analyze images, enabling software developers to easily build applications that can perform different tasks. We will explore them in details throughout the module, but let's give an initial overview of the main service's capabilities. So this service can, first of all, analyze an image, interpret an image, suggesting an appropriate caption, relevant tags, or performing categorization. Secondly, this service can identify objects in an image, detecting human beings in an image, and recognizing famous landmarks and celebrities. Last but not least, it is also able to read text in an image, leveraging optical characters recognition capabilities. I hope we have intrigued you enough with this overview. So now let's get started with image analysis on Azure.
Yeah, so basically to an AI, the computer vision sees an image as just an array of pixel values. And these numeric values, as you can see in the image below, can be used to now train the machine learning models to make predictions on what exactly is contained in the image and the different details about it. Training machine learning models from scratch can be very, very time intensive, requires a lot of manpower, a lot of compute, and of course, a large amount of data. The benefit with Microsoft Computer Vision Service is you don't have to do all this on your own. It's already pre-trained, so it has the computer vision capabilities already built in, and you can just use the service to analyze the images, and it will give you detailed information about what the image is and the different object it depicts. Carlota, how then can we get started with the computer vision service on Azure?
Yeah, so thanks, Bethany, for explaining to us what's computer vision service. Now I would like to cover how to use this service. So first thing first, you need to create a resource for it in your Azure subscription. For doing so, you can use either of the following resource types: computer vision or cognitive services type of resource. So computer vision is a specific resource type for the computer vision service. We suggest you to use this type of resource if you don't intend to use any other cognitive services, or if you need and if you want to track utilization and costs for your computer vision resource separately from the other services. While the cognitive services is a general type of resource for different types of cognitive services, so that includes computer vision along with many other cognitive services such as text analytics, translator text, language and speech services, and others. So we suggest you to use this type of resource if you plan to use multiple cognitive services in your project and you want to simplify administration and development. So whichever type of resource you choose to create, it will provide you with two pieces of information that you will need in order to consume the service. A key that is used to authenticate client applications and an endpoint that provides the HTTP address at which your resource can be accessed. And in particular, if you create a cognitive services resource, client applications can use the same key and the same endpoint in order to access different type of services. Well, so now let's get into the details of computer vision service capabilities by starting with the first visual feature we want to cover today, which is image description. Bethany, do you want to talk us about image description?
Yeah, so as I mentioned earlier, computer vision can be able to analyze an image, and using the cognitive service, it can actually evaluate the objects that are detected and generate phrases and sentences that actually describe what you can be able to see. Depending on now the image content, it can return a couple of results, and these results are ordered in level of the confidence. So it's the level of how confident is the AI that this is actually what it actually is seeing. And the highest confidence phrases will be listed first. For instance, on my right, you can be able to see the Empire State Building in New York, and below there, you can also see the different phrases that are returned. And the first phrase is a black and white photo of a city, which is actually true because this is a black and white photo of New York City. And then the second one is a black and white photo of a large city. Of course, New York is a large city, so definitely this is also very correct. And then a large white building in a city. We cannot be able to tell whether the buildings are white because the image is black and white, but you can actually be able to see from the image that, yes, you can see several white buildings in the image. So definitely it's true. There's a black and white, there's a very large white building in this city. Yeah.
Bethany, I love this feature and think how useful and powerful it could be, for example, if integrated in a solution designed for the blind and low vision community, which open up the visual world and describe nearby people and scenes.
Yeah, actually, if you're there in our last session, we talked about seeing AI. So in the first episode, there's a demo of how Microsoft actually implemented using this vision an application for now the blind, whereby it can actually be able to read aloud what exactly is happening around you, telling you what is there, what is not there. So it's very useful for people who are visually impaired. And the good thing about the application is it's in different languages. So whether you're Italian, Turkish, Dutch, German, French, or even Japanese, you can be able to use the application to see the world around you. Carlotta, how else can we be able to use this service to analyze different images?
Yeah, so let's move ahead with the second visual feature we want to cover today, which is tagging visual features. So the image descriptions generated by computer vision service we just talked about are based on a set of thousands of recognizable objects, which can be used to suggest tags for a given image. So these tags can be associated with the image as metadata that summarizes attributes of the image. This feature can be particularly useful, for example, if you want to index an image along with a set of key terms that might be used to search for the images with specific attributes or contents in a collection of images. So, for example, the tags returned for the same image we just saw with the description visual feature, so the image of the Empire State Building, are skyscraper, tower, and building. So all the objects that the service is capable to recognize in this image. Amazing, right? And the response of the service returns also a confidence score associated to each tag. There's a similar feature to tagging, which gives us further information about the detected objects if they are not abstract concepts. Right, Bethany?
Yeah, this capability is actually can be able to detect the different objects. It's very similar to tagging, but unlike tagging, it does not give you the phrases of what exactly is in the images, but it creates bounding boxes on the image and tells you what exactly is there. So you can be able to see the box and different coordinates on the image telling you that this is a building, this is a tower, and then this is a building, this is also another building. So it actually gives you the exact location where each item is found in the image. This service can also be used to identify popular items in an image, such as brands. Carlotta, can you tell us more about brand detection?
Sure. So let's move to brand detection now. As the name suggests, this feature provides the ability to identify commercial brands. The service has an existing database of thousands of globally recognized logos from commercial brands of products. This feature can be useful, for example, to discover which brands are most popular on social media or which brands are most prevalent in media product placement. When you call this service and pass it an image as input, it performs a detection task and determines if any of the identified objects is a recognized brands. The service compares the brands against its database of popular brands, spanning clothing, consumer electronics, and many more categories. And if a known brand is detected, the service returns a response that contains the brand name, of course, and the confidence score from 0 to 1, indicating how positive the identification is. And a bounding box, so the coordinates for where in the image the logo was detected, was found. For example, in the following image on the screen, a laptop has a Microsoft logo on its lid, which is identified and located by the computer vision service. You can see the purple bounding box on the logo. So this service is not only capable to detect objects and brands. We have more, right, Bethany?
Yeah, the computer vision service can also be able to use to detect and analyze human faces. So it can actually tell you where exactly the human faces are and if there are any human faces in an image. This capability is a subset for those provided in the face service. So if you want more information in related to now the image, something like the emotion or do they have glasses or what their age is or what pose they're taking, you can go ahead and use the face service. But using the computer vision service, you can actually be able to detect the basic foundations of now are their faces and where the face is. This, you can see the example on the woman on top of the rooftop, and you can see how exactly she is and where the face is. So this service not only identifies one person, it can also identify other people in an image. So Carlotta, how does that work?
Yeah, so now let me use the same image we just used, so the girl on the rooftop, in order to explain another visual feature, which is categorization. In fact, computer vision can categorize images based on their contents. The service uses a parent-child hierarchy with a current limited set of categories, smaller than the tags taxonomy, including thousands of tags, while the set of categories is around 86 categories. So when analyzing an image, detected objects are compared to an existing category, to the existing categories to determine the best way to provide the categorization. As an example, the image of the girl on the rooftop is assigned a category of type people. A slightly different categorization is returned for the other image on the right of the deck, which is assigned to the category people group, because there are multiple people in the image, probably family. This is also a great example of the parent-child relationship hierarchy between two tags. In fact, the parent is usually used for categorizing image broadly, while the child to categorize the image specifically. For example, in this case, in the case of the image of the family, we don't know only that there is a person in the image, but we know that there are more than one people in the image. In addition to tagging and high-level categorization, computer vision also supports further domain-specific analysis using models that have been trained on a specific dataset, so specialized dataset. Bethany, can you please explain us a little bit further this feature?
Yeah, so the computer vision service can actually work in two main domain-specific categories. So the first category is celebrities. This service is a model that has been trained to find thousands and thousands of well-known celebrities, whether in the world of sports, entertainment, and business. For example, you can use it to track people like Barack Obama, Cristiano Ronaldo, or Satya Nadella. Are there any celebrities you can think of, Carlotta?
Yeah, Bethany, as soon as I discovered this feature, I tested it with my favorite movie director, who is Woody Allen, and the service was able to recognize him at a very first attempt, so I'm very proud of it.
Yeah, I also used it to test local celebrities. I used to test it on Eliud Kipchoge and Lupita Nyong'o, who are very local to my country, and I was actually able to detect them. So yes, go ahead and use this service to detect the different celebrities in an image. The other thing is it can actually detect well-known landmarks, and for example, you can be able to use it to detect the Taj Mahal, the Statue of Liberty, or on our right, you can be able to see it's been able to confidently, with a 99.41%, detect that that building is the Eiffel Tower, which is very true, as that stands for the Eiffel Tower in Paris. Another interesting use case of this service includes text recognition. Can you tell us more about this, Carlotta?
Sure. So last but not least, the computer vision service can use optical character recognition capabilities to detect printed and handwritten text in images. Also, this feature has a wide range of possible applications. Just to give you a few examples, think about building a solution to digitize handwritten documents, or another solution, extracting text from a formatted document as a CV, and filling in a job application with the information extracted from the CV. As an example, in the following image, you can see that the service was able to detect the presence of text and to extract the words written on the wall of the bank building, so the Toronto Dominion Bank. And what we've seen so far is not all, right, Bethany? We covered the main capabilities, but there are a few additional ones that we need to mention.
Yeah, there are a few additional capabilities. And before I get into the first two, I'll want to urge you to actually think about different scenarios where you can actually implement the different capabilities we've talked about. The first two capabilities are very, very interesting, especially to artists or front-end developers or even designers. The first one is being able to detect the different image types. So you can be able to figure out what kind of an image is this. Is this a clip art or is it a line drawing? The other one is being able to actually generate color schemes for you. So it can specifically identify from an image what is the dominant color, what is the accent color, and then whether the image is black and white. So in case you want to build a color scheme for yourself, you can be able to use this image to now get the colors from an image. So you want to build an application for wildlife, you can get an image from the wildlife, so one for a lion or a giraffe, and now get the colors, extract the colors, and it will give you now the color scheme for the same. What are the last use cases for the same, Carlotta?
Yeah, so you can also use the service in order to generate thumbnails, so creating smart cropped versions of images, keeping only the area of interest. Thumbnails are used to represent images and other data in a more economical and layout-friendly way. And the last feature is content moderation. So the service is capable to detect images that contain adult content or depict violent and gory scenes, and, for example, filter them. So now I think we've talked enough. So we would like to show you an hands-on demo in a way to put into practice all the skills we gained so far. And for that, we have a very nice scenario that I would let Bethany to talk to you more.
Yeah, before we get to the scenario, Carlotta, have you ever been to a supermarket or just a store and you're looking for the grocery side and you cannot be able to find where that side is?
Yeah, many times.
Yeah, I think Northwind traders actually understand the problems you go through whenever you go to a supermarket or a store and you're unable to find which aisle contains certain products. So they decided to make their store smart, and they did this by adding an AI service that monitors from the live feed what the different customers are doing, so it can be able to direct the employees to them. So by using the computer vision service, they are taking images from the different cameras and now analyzing the different images to now get a description of what exactly the image is, and then the captions and the tags from the image. So I think, Carlotta, you can now take us through the demo, how we can get started with now provisioning a resource and building such an application to solve like the Northwind Traders did.
Sure. So I think that Northwind Traders store had a very innovative and interesting idea. And let's show the main steps they should do to make it in practice and use computer vision service. So first thing first, as we mentioned, in order to consume this service, we need to create a resource. So going to the Azure portal, we can click on the Create a Resource button on the top of the home page in order to provision, in this case, a cognitive services type of resource. So let's type the type of resource we need, and let's create a cognitive services resource type. We need to fill a few information like the resource group name. In this case, I'm creating a new one because I don't have one for the demo. Then I need to choose the region, so the nearest region to me, which is Western Europe in my case. Then I need to provide the name of the resource I'm creating. So I'm inventing a name here, Cognitive Serve Demo, a pricing tier, which is standard S0. And now I'm ready to just review plus create this cognitive services resource. Let's wait just a few seconds for the deployment to complete. And when the deployment will be completed, I can go to the resource and retrieve some information. Like, for example, I can retrieve the key and endpoint that we will use in order to consume this service. But first thing, let's open a new PowerShell on the Azure Cloud Shell, because we want to clone a GitHub repo in which we have a ready PowerShell script that we can use in order to consume the service and analyze an image from the cameras of the Northwind Traders store. So let's clone this GitHub repo. You can retrieve the link to this GitHub repo from the exercise of the Learn module. And we are cloning it in a new folder called AI-900. So let's go inside to this folder in the File Explorer view. And let's retrieve the PowerShell script we are going to use now, which is analyze-image.ps1. So Bethany, could you please go through the PowerShell script and tell us more what's inside and what we are going to do by running it?
Yeah, sure. Let me share my screen and go to the PowerShell script. And as you can be able to see, this is a script that will be used to now get the image, analyze, and now get the results of the analysis. The first thing you do is to add your key and endpoint. Of course, your key is to authenticate your endpoint, and the endpoint is now to give you access to the cognitive service. As you do this, ensure you always keep your key private, and you can actually have an easy mask on the Azure when you're using Azure, or you can just ensure that you do not share your key publicly at any point. The next thing after you've imported your key and endpoint is to now import the image. So call the code now for the image. And in this code, we're just reading the image, getting the image file. So we have 3 image files, and now the link to the image, and adding the image file to the end to now complete the image and call the image. The next thing is now adding headers to the code. This is just metadata that you add to your API to make sure that you actually give all the data your API has. So just adding API, your metadata to the API key, and then now calling the body, which now will contain the image URL. After you've now been able to do this, you go ahead and now run the analysis. So invoke the method. So the method you're using is post, and then add your endpoint to the code. After adding your endpoint, add the headers, which now contain the API key, and then your body, which is the URL to the image, and convert it to JSON with a depth of 5. After that, you get the analysis and convert the results from JSON so that you can be able to actually get the details for each. So we are doing 3 things. We are first describing the image, and when we describe the image, we get the different phrases and captions. So we just have one caption to now give us an outline of what exactly is contained in the image. And then the next thing is finding the objects in the image. This will now give us an analysis of what are the different objects in this image. It will return you different tags. And then the last one is now the different tags of the image. So we've been able to now identify the objects. So what tags are now relevant to the image. So I think Carlotta will run the code and you can be able to now get to see what the different items are. Over to you, Carlotta.
Yeah, so let me share my screen again. So at the right side of my screen, you can see the image we are going to use. So an image taken from the Northwind Traders store cameras that we are going to use for consuming the service and to analyze this image actually through the service. So in this image, you can see that there is a woman probably taking a picture of her daughter. So let's see what the service will be able to recognize from this image. So we are going to run the Powershell script, but in order to do so, we need to do 2 edits. So we need to retrieve the key and the endpoint from the resource we just created, and we need to copy-paste these values at the top of the Powershell script, where Bethany showed us that we have the key and the endpoint variables. So let me paste them, and then we can save this Powershell script in order to run it through the Cloud Shell. So let's go back to the PowerShell. Let's go back to the shell. And in order to run the script, we need to go back to the folder AI-900, where we have the PowerShell script and we have this image that we want to pass as input to the service, so to the script. So let's go to the AI-900 folder. And let's run the script by typing the path of the script and the name of the image. Which is store-camera-1.jpg, which is this image that you can see at the right side of my screen. Great, so now we have the PowerShell script printed the result of the service. So as Bethany told us, we consumed the service by requesting 3 visual features: description, object detection, and tagging. As a description, the service returned us this caption: a woman showing her phone to a child. So the service was able to recognize that in the image there are 2 people, was able also to recognize the gender and the age of the people, because we have a woman and we have a child. Was able to recognize the object that the woman is handling on her hands, which is a cell phone, and was also able to recognize the action of the woman, which is handling her phone, probably taking a picture of her child. As regards the object detection, the service was able to identify a cell phone, 2 people, and a room. So was able to identify that, to recognize that the image was taken indoor, so not we are not in the open air, we are inside a room, in this case inside the shop. And tags can give us further information about these images, because the relevant tags associated to this image are text, person, human, shop, and store. Text, the service was able to recognize text in the product packagings of on the shelves. Was able to recognize that we have at least one person in this image, at least one human in this image, and that we are in a shopping store. So again, very accurate list of tags that we can associate to this image. And in our use case scenario of the Northwind Traders store, in particular, the tags feature can be very useful in order to index all the images where there are people that are customers and that can be can need help from our Northwind Traders employees. So this is the end of our hands-on demo. Now I would like to go back to our decks, because it's quiz time. So it's time to exercise and check our knowledge. We will show you a few questions now, and you can answer at the poll link you will see in the chat, and you will see also on the screen. Put yourself to test and have fun with us. For each question, we will give you some time in order to think and answer, and then we will analyze them together to find the correct answer. Bethany, do you mind pick the first question?
Yeah, let's dive into the first question. I like this session because it actually tests whether you understood and you actually are going to apply this. So this session is actually very fun, and be sure to participate at aka.ms/polls. So let's go to the first question. You want to use the computer vision service to analyze images. You also want to use the text analytics service to analyze text. You want developers to require only one key and one endpoint to access all of your service. So what kind of resource should you create in your Azure subscription? Remember, you want to use the computer vision service to analyze images and the text analytics service to analyze text. But you want the developers to only use one key to access the services. So which resource will you use in your Azure subscription? There are three choices. So A, the computer vision service, B, the cognitive services, or C, the custom vision. So remember, we'll give you a few seconds to think about it and answer. And go ahead at aka.ms/polls and give an answer to the question, or you can just post them on the chat. So let's give you a few seconds to think about it and answer.
So Bethany, what do you think?
Okay, let me go through it a bit. So you want to use the computer vision service to analyze text, and you want to use the text analytics service to analyze text. So ideally, this will be two different services, but you want the developers to only need one key and endpoint to access all your service. So this means you have to find a service that actually can do both, use computer vision to analyze images and text analytics to analyze text. So the choices, the computer vision, cognitive service, and custom vision. So the first thing is we're looking at now using the endpoint and key to just access your services. I think the first choice that I'll eliminate is the custom vision, because I don't think it will be applicable in this scenario. So you're left with computer vision and cognitive services. Computer vision is only applicable to analyze images, and you want to do both. So I'm not sure computer vision will be the best way to go. I think the answer is cognitive services. What do you think, Carlotta?
Yeah, I totally agree with you, Bethany. So I think we covered this question both in the module and throughout the module and in the demo, because we actually created a cognitive service resource type. Yeah, so if you want to use more than one cognitive service, I would definitely go with B, answer B. So let's see if the answer is correct. Suspense. Here we are. So B is the correct answer.
Yeah, so we can go to the next question. Carlotta, you can take it.
Yeah, of course. So second question, you want to use the computer vision service to identify the location of individual items in an image. Which of the following features should you retrieve? A, objects, B, tags, C, categories. So again, please vote at the poll or post your answer on the chat. We want to hear your voice. So the answers are again 3: objects, tags, or categories. So these are 3 visual features we covered throughout the module. And remember, we are looking at a feature that identify location of individual items. So first of all, I would probably exclude categories because we are talking about object detection, while categorization is more assigning a category to the whole image. So I would either choose A or B. Bethany, what do you think?
Yeah, I also think the same. So when you're looking at this question, the keyword here is to identify location of individual items in an image. So you're looking at items in an image and then the location. So I don't think categories will give you the correct answer because categories is mainly based on now whether you want to identify well-known images or well-known celebrities, right? And then the keyword here is identifying the location of individuals' items. So when you want to now identify specific locations, you'll need a bounding box to now show you this is where exactly the image is. Tags does not do that. Tags just gives you the different items there. So it will just give you, yeah, this is a tower, this is a building, just like that. But now when you use object detection, it will give you a bounding box showing this is exactly where the tower is, this is where the building is, this is where the cell phone is, and so on and so forth. So yeah, I'll go with the answer A.
Yeah, so let's see if it is the correct answer. Here we are. Yes, objects is the correct answer.
Yeah, so on to the last question. The last question is you want to use a computer vision service to analyze images of locations and identify well-known buildings. So the keyword here is you want to use a computer vision service to identify images of locations and then identify specifically well-known buildings. So what should you do? Is it A, retrieve the objects in the image, B, retrieve the different categories for the images, specifying the celebrity's domain, or C, retrieve the categories for the image, specifying the landmark's domain? You can go ahead and vote for your answer at aka.ms/polls or just type it down on the chat. So the question again is you want to use a computer vision service to analyze images of locations and identify well-known buildings. So take note of that. Analyze image of locations and identify well-known buildings. What should you do? Is it A, retrieve the objects in the image, B, retrieve the different categories for the image, specifying the celebrity's domain, or C, retrieve the categories for the image, specifying the landmark's domain? So I'm sure some of you have already answered. So to get into it a little bit, we are talking about, yes, we're identifying locations, but specifically identifying well-known buildings. This means this is a domain-specific category whereby you actually have the service has actually been trained before and it's identifying a specific domain category. So I don't think retrieving the objects in the image will be enough, as just retrieving the objects in an image will just give you a bounding box and now the results of where it is at. So Carlotta, what do you think?
Yeah, so I agree with you. So we have again a question about location of items in the image. So someone can think about object detection, but in this case, I think that the key term here is well known. So we need a visual feature that is capable to compare the detected objects with an existing database. So we probably need the category visual feature. But we are not talking about human beings or people, right? So I don't think that celebrities is the right domain we need here. So I would probably go with a C. So retrieve the categories for the image, specifying the landmarks domain. What do you think?
I think that's right because we are identifying the specific locations and specifically targeting well known buildings. Let's check what is the answer.
Yeah, let's check. Suspense. C. So good job.
Yeah, so we can give ourselves a clap and then, yeah, over to you, Carlotta, to continue.
Yes, so before coming to an end of this Learn module, we would like to give you a tip. So it's a good idea at the end of a project to identify whether you still need the resources you created and to delete them if you don't need them anymore. In particular, if you created, for example, a resource group for a module exercise and you think you will not use it anymore, a good practice is to remove the whole resource group. And in order to do so, you can use the Azure Portal user interface. So you have a delete button both for the resource and the resource group. And you will be asked to type the name of the resource or the resource group in order to confirm that you want to delete the resource, the item. So please remember that this is a very good tip at the end of your project or at the end of your Learn module exercise. So what we have learned today, Bethany?
Yeah, so today was all about computer vision, focusing specifically on the computer vision cognitive services to be able to now analyze different images. We've been able to cover the different things you can be able to do with the computer vision service. And now we went into a demo, covered now how you can provision a computer vision service resource on Azure. And then we went ahead and did a demo to analyze an image, and you saw the results. And I believe this is a service you should all be using in your applications. So before we go to the end of the session, I have seen some questions on the chat, so we'll just dive into some of the questions and yeah, go with it. So the first question is by Nelly. What kind of business uses this software? So what are the different use cases for the computer cognitive service or computer vision cognitive service? Over to you, Carlotta. Maybe you can give us a few.
Yeah, so I think that this particular service can be really used by a lot of business cases, a lot of business use case scenarios. We gave you an example. So we gave you the scenario about the Northwind Traders store that wants to make smarter its store. But it's you can really use it in a lot of business and markets, such as I can think about the health market. I can think about I also, for example, suggest you the use case scenario of the CV. So using, for example, the OCR capabilities in order to fill a job application, to automatically fill a job application without manually filling all the fields of the application. So it's really very flexible because there are a lot of visual features. So there's no limit about what markets and business can use this kind of service.
Yeah, I think while we talked about the different use cases you can use, we actually mentioned some of the few. Like Carlotta mentioned, you can use it to be able to detect the CVs to autofill instead of you going ahead and now filling all over what is contained in your CV. The other one is how the Northwind Traders are using it being able to now make your store smart and actually detect who are the different people in the store. And then another scenario is the Seeing AI application we saw last week. So the applications are limitless. The next question we have is from Eric, and is asking, can the service consume video data, for example, to check for social distance guidelines? And let me just take this question because I'm very excited about it. So there's this service called the spatial analysis, whereby you can actually be able to tell what people are doing in a video. So what it does, it ingests the video and then detects the people in the video. After it's been able to detect the video, it now gives you insights on what it's seeing. So for example, you can use it in a store to count the different people in the store, or count who is entering or who is going out in the store. And of course, it can actually be able to detect the social distancing. So it can detect whether people are actually social distancing and whether you're wearing your face mask. So of course, it can be able to check for social distance guidelines. I think the link to the spatial analysis will be dropped on the chat, so you can be able to learn more about it. There's one last question. I think, Carlotta, you can read on it.
Yeah, so I really like your demo with the shopping picture. Do you have this demo available in an ARM template? I would like to share it on my GitHub page. So all the information related to the demo we showed you today can be retrieved on the GitHub repo. You can retrieve the link to this GitHub repo on the Analyze Images Learn module. I think you can see the link on the screen. Perfect. So if you go to this GitHub repo, you can see the Powershell script we used. You can see the data we used. So you can also replicate at your own pace the demo we just showed to you today. And we absolutely encourage you to do so.
Yeah, I think we've now come to the end of the session. So maybe, Carlotta, is there anything we need to know?
So you're right. I guess we are coming to the end of this Learn module, Analyze Images with the Computer Vision Service. Again, we encourage you to go back to the module, complete the exercises at your own pace, and apply the skills you gained today. I would like also to remember to everyone that you can take part into the 30 days challenge, a zero to hero learning path with Azure AI. This learning path will drive you towards Azure AI certification. And if you complete the challenge in 4 weeks, so 30 days, you can be eligible for 50% of the cost of a Microsoft certification exam. So don't miss this opportunity. I think it's very interesting.
Yeah, don't miss it. The exam is actually very interesting. So go ahead, attempt the challenge and do the exam. And now you'll go ahead and be able to build different things with now the knowledge you gained. This is not the final session we are having. This is the second episode in the IWD series, whereby we're just introducing you to AI and just helping you to go through the different modules. We have a session next week, same time, same day, on the March 14th. And the session will be now about language, using the language service. So you'll be able to now go ahead and build a bot using the Azure bot service. Don't miss out. Be sure to join in. If you enjoyed this session as much as me and Carlotta did, be sure to join in the next one, because it will be more interesting and it will be more fun. So thank you so much for joining us today. And I can't wait to see what you build.
Yeah, thanks, Bethany, and thanks to everyone for joining us today. Good luck for everyone who is going to take the Azure AI Fundamentals exam, and a very happy Women's Day tomorrow. Bye. Bye-bye.